TPM, Total Productive Maintenance. The intent of these showcase videos that I am producing is not to provide an encyclopedical presentation on the subject matter, but rather to showcase how I have taken a methodology and how I have deployed it myself. But a very basic introduction about what TPM is about would be requisite here. TPM combines the American practices of preventive maintenance with the Japanese concepts of total quality control and total employee involvement. The result is an innovative system for equipment maintenance that optimizes its effectiveness, eliminates breakdowns, and promotes autonomous operator maintenance through day-to-day activities. TPM was conceptualized by a Japanese engineer called Saiichi Nakajima, who was widely regarded as the father of total productive maintenance. For me, this goes back to 1999 when I was the maintenance manager for Alfmeier Corporation, and I was tasked with deploying total productive maintenance. Back then, there was not any consultants that I could hire to educate me on how to go about this. So you have to study it for yourself and do your own homework. And for me, that meant buying and reading and studying up on all of these books that you see here. TPM has 12 steps and 4 developmental stages to it. I completed stages 1 and 2, but when it came to deploying stage 3, having read those books forwards and backwards several times, I decided what better way to engage your workforce than to go to step 8 next instead of step 7, and I'll show you why I did that and what I uniquely discovered by doing so in the next slides. At the time, it just didn't make sense to me to go with step 7 next before step 8, because as I learned with step 8, you can create a groundswell of interest within your organization with conducting these major cleaning events with some of your worst performing equipment and machines. Then after completing step 8, I circle back around to complete step 7. Step 8 of TPM has what I dubbed 7 sub-steps to it, which are: number 1, initial cleaning, which is what this presentation is all about. Number 2, countermeasures at the source of problems. Number 3, cleaning and lubrication standards. Number 4, general inspection. Number 5, autonomous inspection. Number 6, organization and tidiness, which is essentially 5S. And number 7, full autonomous maintenance. The idea was to pick a machine that was one of the worst in reliability and performance output and organize a major thorough cleaning event involving as many company departments as I could volunteer. Now, unlike what it says in the activities descriptor here, as cleaning mainly on the body of the machine or equipment, I wanted to go with a very detailed, deep cleaning, with the idea that cleaning is an inspection and detection activity, and that we would no doubt find all manner of things that need to be fixed or repaired during this activity. I designed and had made these 10 color-coded sequenced numbered category tags of critical sources of interest and what we might likely find in suboptimal conditions during these machine cleaning events. The intent was that during the cleaning process, people would discover items of interest such as loose or missing fasteners, lubrication points, hydraulic oil leaks, cleaning points, mechanical and electrical defects such as broken or bent, missing, worn out tooling, worn parts, worn components, loose electrical connections or frayed wires, inspection or install metrology points such as pressure, temperature, flow, and liquid level gauges, finding also safety defects such as loose or broken e-stops, missing guards, and so on. Finding all of these abnormal conditions that a human being would be able to detect with their sense of hearing, sight, or touch during these cleaning processes. The TPM, as it was called, of course, had to be planned and scheduled. All of the appropriate cleaning supplies had to be purchased, and I had to have plenty of film for the 4 Polaroid Instamatic cameras that I was using back then. Then on the day of the event, I spent about 2 hours educating and briefing everyone on what to do and what we would do in making a very detailed job risk analysis for safe work planning, and to make sure that all sources of energy whatsoever was mitigated and lockout tagout was performed on all sources of power mediums. In all the future TPM events that I led, it was not unusual for the piece of equipment or the machine to look like a Christmas tree afterwards with all the different color tags attached to it. This was our first event with my good friend and mentor, John Petek. John was Alfmeier's production manager at the time, and I'm the one taking the picture, and we did have a lot of fun with these events. Alfmeier owned a car seating division in Monterrey, Mexico, and I was responsible for getting TPM set up and started there also. Now, how these events work is the same people that were involved in the TPM cleaning event would meet up again in a conference room a week later to evaluate all the tagged and photographs of all the instances that they all found to write corrective work orders. I told them to write their initials on the tags and the photographs for identification purposes later so that that person can speak about what they found in each case. Typically, these events would result in anywhere between 50 to over 100 post-event work orders created to fix, repair, replace, and correct everything that we found to be abnormal. We began to notice something following these events, and after all the corrective actions were complete, everything got better. The quality output improved, the operational performance improved, the OEE went up, uptime went up, downtime went down. What's going on here? You clean a machine, you fix everything you find wrong, and lo and behold, it's working better than before. What's going on here? At the same time, I was reading and studying this book, which led me to discover this: the PF curve, which stands for potential failure curve. The PF curve is a graphical tool used in maintenance and reliability engineering to track the health of equipment over time and identify the optimum window for intervention. It represents the life cycle of an asset or component from the earliest detectable signs of degradation, represented at the point P here, P1, to the point where the asset can no longer function properly and it fails at point F here. The y-axis can be a measurement of any kind that is a progressive record of how well the asset is performing its function or component's condition, and the x-axis is a measurement of time, and that time is relative. It can be 5 minutes, it could be 5 years. As you can see on this curve, the asset's condition, if left undiscovered, unchecked, and unidentified, will exponentially decay to its failure point at point F here. By which time, if it's not a hidden failure, you would probably hear it, see it, and most likely smell it by that time when it gets to point F. Remember, these are the conditions that we are looking for in all suboptimal abnormal conditions. This is where they would all appear on the PF curve. So all those potential hidden failures were stopped because we discovered them in time and intervened with a corrective action somewhere along the potential failure curve. Whether it was a frayed wire that would short circuit, blow a fuse next week, to a simple bearing that would fail in a month's time, causing unplanned downtime because it did not have a lubrication plan established for it. I realized that during these TPM initial cleaning events that I had discovered for myself a very good selling point for senior management for the introduction of TPM to whomever company I happened to be working for or consulting for at the time. I could ask them to give me their worst performing asset for a few days to perform the TPM cleaning event on it, fix everything that we would find wrong, and I could guarantee them an improvement. Now, to be clear, cleaning your physical assets every once in a while, finding things wrong and correcting them, is not an appropriate maintenance reliability strategy. How to go about that is another subject for another day. Because things fail for different causes and have different failure modes over time, maintenance has to be a multi-pronged, multi-disciplined approach. And that's a topic for discussion should you hire me as your maintenance reliability manager or engineer. I went on to conduct several other TPM events with Alfmeier and other companies that I either worked for or consulted for at the time, and I made a bit of a name for myself. And I was invited to be a speaker and run an all-day workshop on TPM and 5S at the Advanced Manufacturing Exposition show at the then Palmetto Expo Center in Greenville, South Carolina back in 2005. This is when I worked for Stankiewicz, conducting a TPM event there with the same predictable improvement results. This is when I worked for Fabrical, conducting a TPM event there with the same predictable improvement results there also. Yours truly in the belly of the beast. This is again when I worked for Fabrical, conducting a TPM event there. And here we can see the same predictable improvements in downtime, reducing the downtime after the event and after we made all the corrections. This is when I worked for Tessa, conducting a TPM event there, again with all the same predictable improvements results there. And this is a graphical representation that shows after the event the improvements in uptime with Tessa. This is when I worked for another company conducting the TPM event there, and again having the same predictable improvement results in reducing unplanned downtime. The next two sub-steps in step 8 is sub-step 2, which is countermeasures at the source of problems, which is where you're trying to come up with ways of cleaning prevention in the first place, and sub-step 3, which is where you develop your lubrication, cleaning, bolting, and inspection standards for autonomous maintenance for operators. This is an example of a bolting and cleaning standard. These are tasks for operators to perform that are low in complexity and high in verifiability and do not require any specialized skills, technical training, or formal qualifications. In closing, TPM is a major program, and even for a small company, it's a 5 years commitment to deploy it correctly. And it has been my experience over the years that companies have misinterpreted TPM, thinking that it is just a maintenance program for operators. It is not. It is far more than that. Doing what I did with the TPM cleaning events is a good kickoff for TPM to overcome inertia, and I can help you deploy your own program with my 2 decades of experience doing this. Thank you for watching. This is a series of videos that I will be posting each week to illustrate my experience, knowledge, skills, certifications, qualifications, and what I can bring to bear in your organization. Please contact me at my email at fred@webberking.com. My mobile phone number is area code 864-283-1736. And of course, please do visit my online career portfolio website at fredwebberking.com. Thank you very much. I am Fred Webberking. Bye for now.